Hello guys, my name is John Michael Wilson and I'm here today to tell you about the Niagara Falls Suspension Bridge built in 1854. The objectives are to explain the applied loads experienced in the bridge, go over the structural analysis performed on the bridge, and explain the high level of quality control performed for this particular project. My thesis statement is the Niagara Falls Suspension Bridge was an engineering achievement because of the extreme applied loads it had to support, the level of structural analysis performed on the bridge, and the level of quality control. The applied loads the bridge had to experience were mostly due to human traffic on the bridge. Another main topic that it had to deal with was applied loads that had to deal with were caused by natural forces. The largest portion of load came from obviously the railway traffic going across the bridge. At this time, the railway was being connected between Canada and in America, and this bridge was obviously the first one to do it at this time. It also had to deal with a large amount of load on it from livestock, which is like cattle, sheep, horse, etc. There were also pedestrians and vehicles, which vehicles at the time would have been horse and buggy and the occasional car, but very few of those. It also had to deal with a large amount of natural causes of applied load due to wind or high winds and tornadoes, which is an extreme case of high winds. Basically what happens with the wind is it causes the bridge to want to twist and bend, which can cause it to shear. And so basically they had to perform a very, very strong structural analysis for all of these things to keep the bridge from failing. As far as the structural analysis goes, the first thing that John Roeblings did, which is he was the head engineer for this project, the first thing he did was looked at previous failures in other projects. One of the projects he studied in depth was the Welling Bridge, which the Welling Bridge collapsed because of high winds. It basically was lifted in the center where the cables were tied to support the majority of the weight of the bridge, and it came slamming back down and caused the bridge to shear because of the impact. To prevent issues like that, there were meticulous additions made to deal with the extreme loads on the bridge, with the addition of air-spun cables, which the air-spun cables were only first used in the Niagara Falls Bridge. It also had reinforced girders, which is basically they had larger girders that could that were more rigid to deal with the loads and wind. It had large concrete columns, and it also was the first to ever use cable stays, which is where cables are tied to the bottom of the bridge and also to the ground that keep the bridge from swaying from side to side, keep it from rocking. He also added large reinforced decking to support the load of the train and the horse traffic and cattle traffic and pedestrian traffic on the lower level, below the train. And this picture shows the Niagara Falls Suspension Bridge right after it was completed in 1854. If you look here, you can see the large stone columns that support the majority of the bridge. And then here's the air-spun cables that go from along the bridge to the top part and then back over to the ground. Through here and here are the reinforced girders that spanned the bridge. And then right here is the reinforced decking that was added to the bridge. And then on this lower part is where the addition of the wooden trusses were added. At this time, you would think that wooden trusses would not be the best building material to make trusses out of, but actually at this time, that was the majority of what was available. Steel was hard to come by at this time. The next thing that was really special about this project was the fact that the engineers had to perform their own quality control. Nowadays, engineering corporations have their own construction crews that do their own quality control. With this project, the engineers had to go in after finishing all their structural analysis and calculations. They had to go in themselves and perform their own quality control, making sure that all the materials were the best that they could get for this project. The materials that were available at this time for building were only wood, iron, stone, and steel cable. One of the things they made sure when they were working on this project is they had to have a high enough quality steel cable that it could support the 365-ton load applied from the train crossing the 800-foot span from the 2 sets of stone columns that supported the majority of the bridge. And then the other thing is, with the addition of the wood trusses at this time, that was all that was pretty much available. And then they built the columns out of stone because that was the main material available to them as well. And then here are the references used in my project.